All right, well, I think we should get started. So to introduce myself, I'm Carla and I'm the marketing manager here at FuseForward. And I'd like to welcome you to the fourth episode of our webinar series, Remote Control. So this series is designed to take a quick deep dive into common challenges that IT professionals are facing, particularly as we move to the delivery of online services. So the key feature of this series is that we're quick. We're going to take about 30 minutes to go over the content, but we'll still have time for questions. So please feel free to drop your questions in the Q&A box below and we'll deal with them during the session, or if not, we'll get back to them at the end. So today we have Mark Dam. He's our founder and CTO. And Mark is a skilled systems architect with over 30 years experience implementing complex IT systems for enterprises and the public sector. So today he's going to be talking about remote access. Today he's going to be talking about security for your desktop as a service solution. So I'm going to hand over to him now so we can get started. Over to you, Mark.
Thank you, Carla. Welcome, everybody. Hopefully we're all sitting here and we've got lots of things to learn today and things that we can understand. Today, I'm going to talk a little bit about security for your desktop as a service environment, things that you need to consider and what you want to be able to do in order to go through and create this new environment for you in order to enable a work from home environment. Today, what I'm going to cover and basically go through is just some of the key challenges. Again, this is intended to be a quick review and identification of some of the things to go and consider as you're setting up your desktop as a service, and some of the ways to go through and the challenges you run into and the things that you're going to do in order to address those. So let me move on. Let me give you a little stats right now about some of the challenges right now. About half of businesses have had and experienced an attack. So what is this? 40%, 46% of businesses have experienced an attack of some sort of a phishing or some sort of cyber attack in their environment. More than half of these have been phishing incidences. So what does that mean? It means that somebody's sending an email through, trying to go through and get credentials from users, and then using those credentials to actually log into the environment. And then, of course, 49% have anticipated a cybersecurity incident. So that could be somebody coming in for a denial of service attack, could be somebody trying to get through the network and steal all of the data out of your environment, trying to get credentials to users. So that environment that we look at, as soon as we start using a desktop as a service, or even with our desktops and we're starting to expose our corporate networks to the internet, we're now subject to a larger attack surface on which end users are going to be hit with. When we've done everything inside, when we had a network inside our enterprise organization and it was all locked down and nobody could get access to the internet, we didn't have a problem as much. But as soon as we start using a desktop as a service, our users are out there and they're going to continue to be going through and be able to be increase the attack surface and are going to be hit by potential incidences of cyber attack for those bad actors. What's interesting that I've been reading recently is that if you even look at what's going on with the pandemic right now with COVID, we're seeing a lot more attacks coming through because of the work from home movement. With work from home, we basically ask the question, well, what should we be doing? Should we be giving people and allowing all of those unsecure personal desktops and laptops to be used? Or should we be using more desktops, which are virtual instances sitting in the cloud that we can put an extra layer of security around? So let's talk about the ones where we start now using that virtual desktop in the cloud and things that we can do to make sure that we're managing its attack surface and decreasing the incidence of cyber attacks and phishing expeditions. So let's go back and I'll just show you. Experienced an attack, just to summarize, 46% have experienced an attack. More than half of those have been phishing, and 49% are anticipating an additional cybersecurity incident in the coming days. So that's a lot. So how do we go through? So if you're going to use virtual desktops, the biggest thing you need to do is make sure that it's secure, but only if it's configured correctly. So how do we go through and deal with that? Attackers are using a lot of automated tools today. So just like in what we call DevOps, we're able to go through and create our own automation mechanisms. Just like we as enterprise users and managers and IT professionals are doing that, the the threat actors out there are also doing the same thing. And they're using that as a mechanism to go through and put bots out there to continue to look for holes in our security perimeter. So how do we go through and handle all of this? How do we start looking at things that we can do to manage and configure and make sure there's no misconfigurations? Interesting little stat for this. When we start looking at some of the recent incidences of cyber attacks where there's been theft of data, the data hasn't been because of a hacker getting through a firewall. The theft of the data is because of a misconfigured data store where there's been a hole left open that allows a bad actor to walk in through. So that's what we've got to be doing, is looking at the configuration parameters and things that we need to consider around our desktop as a service offering. So let's look at challenge number one. Okay, challenge number one is the perimeter. So what are the potential risks? If your data is exposed to the internet, you have hardware and software misconfigurations, you leave firewall ports open. If you leave a port open, an actor out there has got this chatbot going and trying to fish out and say, is there an open port? All right, if there is, let me go through and see if I can get through it. And then when they get through that open port, what do? Well, that means that they're now into at least the first perimeter of a security envelope. And what they want to be able to do is see if they can go through that. So the second part they do is, let's say it's not a port, but you're using something like a Microsoft Azure or an AWS storage infrastructure, and you've got, say, S3 and AWS as terms, and what you're going to do is you leave that so that it's open to public access. We've seen a number of large major corporations have that issue, where then once they leave that S3 bucket open up to the world, all of a sudden whatever's stored on that is also accessible by the bad actors. So what are the things that we can do in order to go through and make sure that we've got our configurations all in place? So with the perimeter, number one, use firewalls. So as an example, when they come out the door, firewalls may have certain ports and they have certain things configured in them, which is everything is open. First rule of thumb, always turn off everything. So when you configure up your firewall, make sure that your firewall has got all ports closed and only open the ones that are required. That's a complete best practice. Okay, adequate number of client ports. So let's say that you're now going to go through and you've got your firewall infrastructure and you have enough access through there, but do you have enough throughput? Do you have enough VPN service? Is your network fast enough to handle these new virtual desktops? Virtual desktops, by their definition, are actually a desktop that has to go through and stream the front end screen to a laptop or a desktop computer, a physical device. So what are some of the things that you can do that? Well, you can go through and make sure that you have a burstable VPN so that it can scale out as more users are going through, and that you had enough bandwidth support in order to go through and let your home users access it. So as an example, a home right now, what I've seen on my personal home network recently is throttling by the telcos, the internet service providers. So while I have a 300 megabit MB system at home, what I'm actually seeing in some cases is it drops down to 10, 15, or even 20. Why? That could be more and more people concentrating in through that. And then when they're trying to hit that goes into the internet, then it has to go and branch out onto the side where it's actually getting into your servers and your desktops inside the cloud. So you need a big enough pipe on both the ones for the home user as well as the ones on the other side to go through and handle that perimeter and the security risk associated with it and the number of traffic. One of the things that we look at on the perimeter is if we've got our desktop as a service, we're also subject to things like denial of service attacks. So we want to be able to go through and move some of the IP addresses around to go in and basically stop any sort of attack on the perimeter. So let's talk a little bit about user identity. Challenge number two. Okay, so users, if we look at it, this is where a phishing expedition comes in. I'm not sure how many people understand what a phishing expedition is. It's not going out with a rod and a reel and trying to go through and catch fish, but it's very similar to that. What the bad actors do in this case is they go out there and they try and send out emails with little tags on them, and they try and get users through an email system or some other type of infected payload to get it clicked so that it can be exposed and installed on a desktop computer. So a desktop or even a virtual desktop, same issues exist. How do we go through and stop that actor from going through and doing that? And then of course, that's one way, because once you've got a piece of software installed on that desktop, You basically are at the point where they can start monitoring keystrokes, they can monitor what you're doing, and once you do that, they have the ability to grab usernames and password credentials in order to get into the system. All right, so how do we deal with stolen credentials? What other ways can we deal with on stolen credentials? So the other way in some phishing expeditions is they go through and they try and get you to go and respond to an email, and then they start asking you, can you please give me, I am from the Microsoft support desk, can you please give me access to your computer with your username and password, and I'll be able to log in and fix your problem. We've all heard those lines. They've come through my phone many times, and I always like to engage them a little bit and say to them, hey, tell me, Mr. Microsoft Support Desk, how can you help me go through and fix my computer? What's the password that you need and what's yours? And of course, they don't really like that, but that's part of the way that they go and get stolen credentials. So what are the kinds of technology that we can use to manage user identity and the password rights? Well, once we set up VPNs, even with a desktop, when we start using VPNs, that's one way, but really the virtual desktop is the path to get in. So even though we can have a virtual desktop, the first thing we want to do is manage the authentication, the credential process. That's password management. So instead of just using a username and a password, add multi-factor authentication. So what does that look like? So the way that I get in right now is I use my username. I have to use a password. Then I have to go through and use my phone to go and look at my face because I have an iPhone, who will then go through and give me a code to go through and type in addition to my password to get into the system. What that does at the end of the day is it starts to go through and create additional, it starts to create additional ways of going through and forcing additional passwords to be done. So that's one part of password management, okay? We also have a question just kind of came in a little bit on that. So see if I can answer some of those things. What is the best way to manage passwords? Passwords are best managed using single identity stores. So we basically go through and also think about federating, what we call federating passwords and identity service providers together. That gives us the ability to link into single sign-on. So some of the passwords that we run into, we want to go through and have different ways of having complex passwords, but the challenge is, and there's always some debate now, is whether we want to continually to change those passwords every 90 days, or just add more factors and get into what we are now seeing emerging as passwordless processing, which also includes things like using biometrics and other types of identity verification methods. Okay, so those are all of those. One of the things that we do in Fuse Forward is we use a product called Fuse Access, which is our single sign-on infrastructure. We integrate in identity stores from all the different providers and all the different customers, and they manage the password resets process themselves. And we start looking at different ways of using what we call IP rights management and IP whitelisting to make sure that only those with secure locations are actually able to log into certain environments and services as well. Okay. So I'm going to move on to challenge 3 here, okay? Challenge 3, which is connectivity, okay? So if we look at connectivity, we basically are running into issues with your virtual desktop, and home users are saying, well, I can't access the application because I can't get in right now, okay? So what we start seeing is applications are exposed to the internet potentially because we're now doing a desktop as a service, but are they? Okay, there's a couple of different ways that we can start looking at, which is how we want to go through, and do we really want to expose our customer billing system or a financial system to the internet and use basically a browser to access it? I don't think so. That kind of creates what I always look at from managing connectivity is we want to create these layers. Layer 1, perimeter, which is the connectivity perimeter. That's where your virtual desktops exist. Then they have to link in through another mechanism, which is now a secure edge. And then on the secure edge, we then get into application networks. And then even beyond that is the database networks. All of these networks are connected together, but we put different firewalls and different perimeters around each one. So all of that requires a certain level of firewall protection and connectivity through all of those pieces. So the potential risks of our desktop as a service not being able to access in is how can we go through and link into the different kind of accesses and applications through that. So technologies we can use. One of the things we do with our desktop service is we think about having the client themselves use some sort of virtual private network from their physical device at home and link into a VPN landing zone. So that's creating even a tighter one. From that VPN landing zone, that's where they then launch a virtual desktop. Okay, so that's one way of further locking down the virtual desktops. Second way to do this is to use your virtual desktop. It's an application itself on a laptop, but it creates a secure environment on which to launch the desktop services. And then from that, we then go through and say, well, from there, I can go through and access through a VPN to get into the additional applications that are inside my corporate network. So you can either put a VPN on the front or put a VPN on the back behind the virtual desktop, but adding in a VPN into that whole front end perimeter helps to further manage and lock down the connectivity of the virtual desktop so that bad actors can't go through phishing expeditions and just try and arbitrarily go through and get access to those systems. So I'm going to go through, I know that there's a number of questions. What we're going to do is I'm going to cycle back a little bit and do some question and answer at the end. But what I want to do is I want to jump into the last challenge here before I answer some questions, if that's okay. The next one, the last challenge that we kind of see with virtual desktops is, what about the desktop image itself? So if you listen to the first three challenges, 1, connectivity, 2, perimeter security, and 3, basically going through and understand how phishing expeditions go along, okay? Well, what do we have? In all cases, I've talked about a physical device out in the field or in somebody's home being used to actually access the service, okay? Well, if their computer at home is not a secure device itself, how can we better lock that device down? Okay, so when we think about that, when we start looking at our images, the challenge that we have with any Windows-based or Linux-based desktop image is that once you're in, if a user has administrative rights to it and can install software, or if they're running a mail client, they're potentially going to be able to hit something that could try and get at system files and be installed on that image itself. So how do we go through and deal with the desktop image itself in a virtual desktop? Number 1, deal with and build standard desktop images and turn off all of the administrative capabilities for the end user. Just like we do with on-premise desktops, lock down the rights on that so that it can't have images or software installed on the actual desktop image itself. That includes, don't have a local file storage for data, okay? Use something like a file storage as like a file server instead of a desktop. Now, does that open up some additional ones? Could be, but you know, many of the applications that we run in the corporation today are desktop or images or web-based applications. For each one of them, you don't necessarily need to, in many cases, you don't need to at all, store anything locally other than the application binary files, if it's a desktop image or a desktop application, or if it's a web-based application, you don't even need to store anything and you just need some caching data. So in those cases, lock down the image. Don't put anything on it. Don't open up a local file storage at all. And then that starts to lock down the image. And also, one of the recommendations we have is don't put a mail client on it. To stop the phishing expeditions, you can put your mail clients outside on the user's personal desktop or their mobile device. We all know that email is just one means, but keep the email system away from the actual physical desktop access devices. That way, email is the one that everybody tries to use, and what we're seeing more and more is instead of using email, they're going to chat functions, and they don't stop any sort of data upload capabilities into those services where you're doing files. Files that are infected are the pieces that have payloads which are damageable. So let's stop the update and the attachment of infected images. The last way, and this is what this technology is, I'm not sure if people understand what PC over IP, but it's basically, it's kind of like similar to your virtual desktop is in the cloud, but what you're doing here is instead of using a physical laptop or desktop to access it, you use a smaller device. And that little device is what it does is it can be turned off, so it doesn't even have any peripherals attached to it. The only thing you put into it is a USB enabled, or you basically put in a keyboard, a mouse, and what it does, it has a network file, it has a card on it that will accelerate the graphics so that you can basically see on your display what's being displayed on your virtual desktop. It's almost like what in the past, for all those people that understand what mainframe computers are, it becomes a dumb terminal, and it accelerates the way of actually going through and seeing what's on your virtual desktop without you actually running a physical desktop at home. Those devices are great for operators. You know, people running critical infrastructure systems that want access to a SCADA or a real-time control system, people that are going to be running different kinds of controls and management systems where they need a much higher level of security, and they don't even want to have attached to their virtual desktop environment physical devices that are not part of their corporate standard. So those are things where we can now look at PC over IP. It was invented by a company called Teradici out of Vancouver, and it's now being supported by all players, including VMware, AWS, and Azure for their virtual desktops itself. So hopefully that gives you a little bit on some of the four key challenges that you run in order to secure your virtual desktop environment. What I'd like to do right now, just before we jump into the last, is look at some of the questions that I've seen come through on the chat. See if we can go through and answer some of these. Question number one, is it safe to use a free VPN service advertised on the internet? Well, let's understand what the advertised VPN services on the internet are really about. A VPN service on the internet is not necessarily securing your corporate network. Your VPN service on the internet is actually a means for your home computer to connect into a VPN cloud, if you want to call it that. Don't tell people where you're coming from, and then connect to an open alternative VPN or internet service on the other side. So it's not actually securing anything between your home and the actual service on the other side, other than masking where you're coming from. Okay? So it does secure part of your home network, but it doesn't secure your corporate network. So it provides a little bit, but at the end of the day, you're either going to have to choose to use a VPN service on the internet for your personal use, but when you're running a corporate environment, you're probably going to not be able to use that service to access your corporate VPN service, which is a completely different VPN environment. A corporate VPN landing zone is really an equivalent to these advertised internet VPN landing zones, but what they're doing is forcing a secure connection from your home to your corporate internet, and it should be a separate VPN tunnel. Let's look at one of the other questions that came up. How easy is it to set up end users with multi-factor authentication? Okay, so how easy to set up users with multi-factor authentication? Well, there is ways to self-enroll a multi-factor authentication service. So if you've seen this, I actually have an iPhone. Okay, there's my iPhone. And what I have on here is it has a camera on it. When you go through and use the camera, there's usually a self-enrollment process where you can actually take an image, and there's when you're enrolling your service for a token, you basically are going to take a picture of one of those images, and the phones will recognize that token. Once you're in there, your phone becomes the token. So you can basically set up for end users a simple multi-factor authentication process. Okay, you can force that as well, and that's part of the process that we look at. For non-technical users, in some cases, it's a little bit more difficult, especially grandma and granddad. They're sometimes trying to figure out how to go and do that. And that's where you sometimes need to have somebody go through and do the enrollment process for you and work with a service desk or a service provider that can help you manage and operate that service on their behalf and provide service desk capabilities for that. By the way, that is something that FuseForward provides. Another question. What are the different options for MFA? So multi-factor authentication, things that we look at as different options for that. One is things like a software token on a phone. Those are the ones that are becoming more and more relevant. Why? Because everybody's carrying their phone around. And it becomes what we call a soft token mechanism, where we don't have to carry a second set of keys or a second physical token that's out there. Second type is what they've got is a physical token. usually is shipped to somebody, and those come in two models. A physical token can be something that has a number on it, like an RSA key, that kind of you type it in and it's linked into the company's own private key structure to go and authenticate and verify the end user. The third way is other ones which are new types of devices. YubiKey is the one that we also use. And that's one where you basically have one-time passwords that are generated as part of that process. And it becomes a little device that you put into a USB slot. So you have to have it and you tick it and it verifies that you have that device with you as well. So if you look at it, we're moving more and more away from passwords. We're using things like one-time token mechanisms, and we're looking at biometrics, where we're using things and coupling that with things like a biometric system on your phone, where we're either using fingerprints or a facial recognition technology to do that. Last question. What kind of hardware is required for PC over IP? So PC over IP, the device looks a little bit like it's a little device you can get from many vendors. They come from HP, Dell, they come from Wise, they come from multiple different vendors that have created this little device out there for PC over IP with a single card in it. That device itself is in there. It requires a server on the desktop side and some additional infrastructure within your virtual desktop environment to handle and replicate the sessions onto those devices. And then you have a physical device that sits in the home or in the secure operations room that basically connects to that streaming server to convert those graphic images from the device on the card to the home. So you got a device at the home or in the ops center, and then you have a server which basically connects into the virtual desktop and handles the connection strings there. I hope that helps. That kind of I see the questions and answers, and hopefully I've gone through all the various questions that we've had today. What I would like to do is share a little bit on this call. I mean, we're coming up to the half hour here, and we like to keep these to a 30-minute window here. For a limited time offer until June 30th, we do have a offering out there, secure virtual desktops. Receive up to 50 users in our enhanced security until July 1st for free. Try it out, see if it works, and validate that you've got something able to go through and use. And you can see that, look at our webpage for more information. Visit our webpage at Secure Virtual Desktop Services on the internet. And from there, I'd like to go through and hand it back to Carla and let her go through and do our wrap up for us.
Yeah, great. Thanks for that, Mark. That was really interesting. I'd just like to say we'll be sending out details of the offer following this event. So keep watch for that. And I'm just going to flick my video on so you can see me again. Hi. So yeah, we'll be sending details of the offer out along with a recording of this webinar. And I'd also like to draw your attention to the next one, which is running critical infrastructure from home. And that's a technical deep dive on how to run critical systems with high security needs from home. So that should be an interesting one. And it's a focus on, you know, critical infrastructure providers, utilities, healthcare, cities, but, you know, anyone with security needs, this will be interesting for. So we'll be posting a link to that in the chat. And again, we'll be sending it out afterwards. And if you'd like to learn more, we subscribe to our series. You have the URL there. You'll update you of what's coming up, and you'll also be able to access past webinars. So thank you everyone for your time. It was a great session this morning. And if you have any questions, feel free to reach out to one of us. Thanks.